Question 3, select the correct answer. Consider the parent function f of x equals e raised to the x power and the transformed function g of x equals f x plus 3. Which feature of function f and g differs? Okay, so first off, we've got the transformation rules over here for exponential functions. They're pretty much the same thing for any function, but this looks a lot different than this. So I'm going to write down the general transformation rules for any function. So if you have a function in this format that looks like this, the h value is the horizontal transformation. The k is the vertical. Really, that's all we need to know for this particular problem, because we can quite clearly see we have a positive 3. So this is going to shift the parent function left or right. Now over here, this gives more specifics in detail for when we shift left and right. So if we see a positive, we're going to shift left. If we see a negative, we shift right. Well, what do we see here? We see a positive. So we're going to take this function and we're going to shift it to the left in this problem. So I want to get a visual, though, of this problem. So I'm going to rewrite the parent down here just so it's a little neater. This is the original problem, the parent. So I just rewrote it. If we're shifting to the left, like we said, that means this value is positive. So the new function g that we're going to graph in the calculator is going to be e raised to the x plus 3 power. So let's go to the graphing calculator. Of course, you can find a free graphing calculator online anywhere. Just Google free graphing calculator and you'll find one. So to get e, first I'm going to graph the parent function. To get that, I'm going to do second division sign. That gives us the e. Raise to button is just above the division sign. This is pretty standard on any graphing calculator. And then I'm going to type in x. I'm going to graph it to get an idea of what this graph looks like. That's the parent function. Go back to y equals. I'm going to go down to y2, and I'm going to type in the transformed function. So second division sign gives me the e. The raised to button is above the division sign. X plus 3. Graph it. And again, we can see clearly this has been shifted to the left 3. So now we've got a visual, so it's going to be easier to answer this question. Remember, the actual question in this problem is which feature of function f and g is different. So domain are the x values that are covered in this graph. So it's how far left and right a graph goes. Well, we can see both of these graphs, if we extended them, are going to the left forever, and they're going up and to the right forever. So the domain is the same for both of these. It's not going to be it. The range is also the same in these, because the range is how far up and down the graphs go. It's the y values. So both of these graphs obviously go up forever, and both of them are approaching the x-axis, but never quite touching it. So they're not going any lower. They're not getting into the negative y values. So the range is the same. The domain is the same. The horizontal asymptote we just talked about is the same. The x-axis is the horizontal barrier or asymptote for both of those graphs. It's the y-intercept that's different. And we can see clearly the y-intercept for this graph is right here. Doesn't really matter what point it is. It looks like it's somewhere right around 1. In fact, it is 1. This other y-intercept, we can't even see it, but we can tell it's going to be way up here. So these graphs are intersecting the y-axis at a different point, so that's where they differ.